this class, we will quickly simplify this DC network having dependent source, and we will find the magnitude of V0, means the magnitude of this voltage source, and the current supplied by it. Assuming power loss in the load resistor, means power loss across this 2 ohm resistor as 18 watts. So let's proceed. First we will assume that the current supplied by this voltage source V0 as I, and we can see here that this is our dependent current source, and from this arrow we can easily identify that this is a current source. The magnitude of the current of this current source is 2V, where V is the voltage drop across this 5 ohm resistor. Here we have a parallel branch of two resistors having values 2 ohm and 4 ohm. So first we need to simplify this parallel branch and we need to find the equivalent resistance value. Now if the equivalent resistance value is RQ, then it will be 2 multiplied by 4 divided by 2 plus 4 ohm. So now instead of these two parallel resistors, we can imagine that as if we have a single resistor having value 4 by 3 ohm. Now this forms this voltage source V0, this resistor 5 ohm, and that equivalent resistor 4 by 3 ohm. They form a loop, and in that loop the current which will flow is I. Now as per the question, we know the power loss across this 2 ohm resistor is 18 watt. As this is a DC circuit, so we can say that the power loss or power consumed by this resistor will be the square of the current value flowing through that resistor multiplied by the resistance of that resistor. Now we know the power loss value and we also know the resistance value. So I will be plus minus 3 ampere. Now plus 3 ampere will be when current is flowing downwards, and minus ampere will be when current is flowing upwards, because in this part of the circuit we know this is the only source. Here we have the dependent current source whose direction is upwards, so current will flow this way, and at this point, at this node, it will be divided into two parts. One part will be flowing through this branch and the other part will be flowing through this branch. So that means through this 2 ohm resistor or load resistor, the current that will be flowing is downward. So that will be the actual direction of current, and with respect to that direction, the current value will be plus 3 ampere. Or we can say that if we take plus 3 ampere, that actually signifies that through this 2 ohm load resistor, the current is flowing downwards. Now we'll come to the leftmost part of this circuit, where we have already simplified this parallel branch, and instead of that we will be having a single resistor having value 4 by 3 ohm. So since the current supplied by this voltage source is I, so that current will be flowing through this 5 ohm resistor and also the equivalent resistor 4 by 3 ohm as well. So these three components, voltage source and these two resistors, as we can see, they are forming a loop, and in that loop the only current which is flowing is I. So here we can apply the loop analysis or mesh analysis concept. So by applying the mesh analysis or loop analysis, we can write plus V naught. As we can see, we are moving from negative to positive terminal of the voltage source, and if we apply that convention as positive, then here for this resistor we are moving from positive terminal to negative terminal. So it will be minus V, or we can say minus V means it is V is equal to IR. So current value which is I and the resistance value which is 5, and then again through this equivalent resistance which has the value 4 by 3, to that equivalent resistance also the current will be flowing downwards, means this will be the positive terminal, this will be the negative terminal. So it will be also I, the current value multiplied by the equivalent resistance 4 by 3, and that will be equal to 0. So after simplification we are getting V naught as 19 upon 3 multiplied by I, or we can say I is equal to 3 upon 19 multiplied by V naught. So this is the relationship between the current supplied by that voltage source V naught. Now again, if we look at this part of the circuit, we can see here that the voltage drop across this 5 ohm resistor is V. So as per Ohm's law, that V will be current which is flowing through that resistor, that is I, multiplied by the resistance value, which is 5. So it is 5I. And what is I in terms of V naught, that we have just now derived, and that is 3 upon 19 into V naught. So it will be 5 multiplied by 3 upon 19 and then V naught. So it will be finally 15 upon 19 then multiplied by V naught. So this is the relationship between this small v and this V naught, and small v is very important because this is the value on which the value of this current source depends. Now if we come to the right side of this circuit, we can see here we have a node here, and at that node these three branches are connected. So we can easily apply node analysis concept at this node, where through this branch the current is entering this node, and through this branch the current direction is not given. So we will assume as if the current is leaving this node, and this node will be taken as reference node, and through this branch also current is leaving, and that value we have already calculated, which is 3 ampere. So let's apply node analysis at node A. Now if we apply node analysis at this node, then the current value through this branch is to V, where we know that what the small v value means, that will be equal to the summation of the all the currents that are leaving this node. So through this branch the current value will be the potential difference between these two nodes. Now potential of this node was not known, so we have assumed as that as VA. So small va minus the potential of this node. Since this node was taken as reference node, so that means that node has been grounded. So potential of this node is 0, divided by the total resistance of that path, which is 2 ohms. So divided by 2, plus the current which is also leaving this node and that is flowing through this branch. Here also the potential of this node VA minus, this is the end node or second node for this branch, so that minus 0, divided by the total resistance of this path. Now we can easily see that 5 ohm and 2 ohm resistors are connected in series, so their resistance value will be simply added. So it will be 5 plus 2. Now from this circuit, this part of the circuit, we also know that the potential difference between these 2 points, which is VA minus 0, that means VA only, that will be equal to the current value which is flowing through this path, and that current value we have already calculated, that is 3 ampere. So that current multiplied by the total resistance of this series path, which is 7 ohm, so that is 21 volt. That means we can say that 2V, that will be equal to 9 then multiplied by small va, which we have calculated as 21 volt, divided by 14. So we can say small v will be equal to 27 by 4 volt. Now here we have developed a relationship between the small v and capital V naught. So from here we can say capital V naught will be 19V divided by 15. And what is small v? Small v is 27 upon 4. So the final value will be 8.55 volt. So one of the parameters we have already calculated, which is V naught, and the other parameter that we need to, or we were supposed to calculate, was I, the current supplied by this voltage source. Now we have already developed a relationship between this I and V naught, and that this is the relationship. So we will use that, and we already know the value of the V naught, so we can easily find the value of I as well. So I was 3 by 19 into V naught. So 3 by 19 and V naught, the value is 8.55 volt. So since this is I, so this will be ampere. And if we further simplify, then the value will be 13.5 ampere. So these are our final value. V naught is equal to 8.55 volt and I is equal to 13.5 ampere for that given circuit. So I hope this class was meaningful for you. With that, hope I end today's class. Thank you.